squared. Okay. Plus nx squared plus nz squared times k0x k0z times the c zeta. Okay. And nz squared k0z squared zeta squared plus 1/4 capital omega squared times, I may write this on the other side, 1/4 omega over c squared times nz squared minus nx squared times ny squared minus nx squared and the nz squared minus ny squared times eta squared. The left-hand side is the bilinear form of cos and zeta, which means we can change coordinate axis, change the orientation of the coordinate axis to diagonalize this expression, to make it as the sum of square. Okay. And on the right hand side, we have some coefficients times the square. So what does this mean? Let me show you a simpler example. Suppose I have an equation of this form. Z and x, y, z is equal to k times c times rho. Rho means square root x squared and y squared. The radius from z-axis to the surface, and the c is a constant. This describes a cone. If c is positive, I get this cone. And if c is negative, I get this cone. Okay? And I can write this as c squared equal to c squared times rho squared, which means c squared times x squared plus y squared. So on one side I have a single square. On the other side I have the sum of two squares. Okay? This describes a cone. Here similarly, through coordinate transformation, I can make the left hand side as the sum of two squares. And the right hand side contains only one square. So this also describes a cone. we can generalize this. For example, suppose I have z squared equal to x squared over a squared plus y squared over b squared. This cone is a circular cone, and this cone is an elliptic cone. Okay, 就是说，if I consider the cone intersect with the plane is parallel to the xy plane, then this gives us an ellipse, and this gives us a circle. Okay, so in general we have elliptic cone. Okay, so this in the general case, so this gives us an elliptic cone. Okay, to make it a standard cone equation, we must rotate the coordinate axis. This direction is perpendicular to the circle, and we have the other direction perpendicular to the ellipse. In between, we have a direction in between. Suppose this angle is chi and this angle is chi. We can show that how to say? We can rotate our coordinate axis so that we have one axis along this direction and the other coordinate along this direction. This direction gives us c, and no, this is not c. This direction gives us c. This direction corresponds to zeta. We must rotate the coordinate axis. So once we choose the correct coordinate axis, we can make this we can change this equation into the standard form. The derivation details, I have written down the derivation details in the note, and I can send the note to you later. Okay， 我不会考这个啦，期中考不用担心，我不会考这个推导，但是观念是有可能考，观念，就是说 you do not need to know all the details of these derivations, but you have to know the concept. OK， 好，那这边的话呢，就是最后推出来的标准的空的方程式长这里啊。This is the final form of the cone equation. And corresponding to this cone describes the K. We can derive another cone equation describing the group velocity. the group of velocity is described by this cone, VG. Okay? And so I have already explained the phenomenon called conic refraction. So up to this step, you can understand that this equation describes a cone. So we can change our coordinate axis. We can rotate our coordinate axis to make this the standard form of one side of the cone equation. And then finally, we can understand that this equation describes a cone locally. Okay. So since k vector k vectors are lying on the cone, so the corresponding group of velocity have a cone also. Although these two kinds of cone are perpendicular to each other. Suppose this is the cone for the group of velocity, and this is the cone for the k vector. So this vector, this k is this incremental of k vector is perpendicular to the this group of velocity is perpendicular to the k cone. Okay, this group of velocity is also perpendicular to this k cone. Okay. So we have two kinds of cone. This describes the k vector. K0 plus alpha. And this cone describes the group velocity of k. Okay. What determines the propagating direction of the beam? This cone. Okay. Because energy flows along the direction of group of velocity. Okay. 这个就是所谓的 conic refraction。好，那后面还有4至9节叫做 optical activity， 还有 couple mode theory， 这些东西都有很多的细节。好，那我觉得就是说，在期中考之前，我们先不用教这个东西，我决定接下来直接教第5章。好，然后这些很啰嗦的东西，我们留到后面有空再教。好 ，So I will bypass section 4.9 and 4.10, 4.11, and 4.12. I will come back later if I have enough time to teach them. Right now we move on to chapter 5 because chapter 5 is more important than the later sections in chapter 4. OK， 好，那在我们进入到第5章之前，我先来勾一下第4章的作业啊。这5题，好，1、2、3、4、6，好，我已经刻意挑过让你们比较好写的，好，好，
我们看第5章。
Now I teach chapter 5. Chapter 5. Jones calculus. This 主要教 Jones calculus and is application. To by refrigerant optical systems. Okay. So the basic idea is very, very simple. Much simpler than we have already told about, say, biaxial crystal. Okay. So suppose I have a block of a piece of crystal, and the c-axis say uniaxial crystal, and then its c-axis is parallel to the surface, this surface. Okay, c-axis. Suppose I consider uniaxial crystal. Uniaxial crystal means that epsilon x is equal to epsilon y is equal to, say, epsilon O, and the epsilon z is equal to epsilon E. Okay, and the c-axis means the z-axis. So I cut the crystal and give the surface perpendicular to the x-axis or y-axis. Okay, so the z-axis is parallel to this crystal. So if I look at this plate, this is a plate, then the c-axis may be pointing along this direction. So along this direction, we have epsilon equal to epsilon E. And in the direction perpendicular to this direction, we have epsilon equal to epsilon O. So epsilon E corresponds to refractive index NE, and epsilon O related is corresponding to refractive index NO. So if we consider positive uniaxial crystal, then we have NE be larger than NO. So if NE is larger than NO, then if I send a beam of light into this wave plate, I consider sending a beam of light normal to this plate. And if this beam, the vector is parallel to the c-axis, then we have this beam propagating inside this wave plate, having the speed of light in the crystal equal to, say, v E ray equal to c over NE. However, if we choose the polarization to be perpendicular to this c-axis, then we have EO ray, the velocity is equal to c over NO. Okay. Now the E ray and the O ray have the same direction, propagating direction, because now the c-axis is parallel to the crystal surface. Okay. So since NE is larger than NO, so this gives us a slow speed or slow velocity, and this gives us a fast velocity. Okay, so in this case, we say the c-axis is a slow axis, and the direction perpendicular to this c-axis is fast axis. Okay. If we use a negative uniaxial crystal, then this gives us a fast axis and this gives us a slow axis. Okay. So if we cut the crystal so that we get a surface perpendicular to one optic axis, in fact, perpendicular to one principal axis. Okay, so we get a wave plate having one axis represent the slow axis, and the other axis play the role of fast axis. Okay. So, what's the use of this wave plate? Suppose I send a beam of light having polarization along an arbitrary direction, which means that this E vector has two components. One is parallel to the c-axis, the other is perpendicular to the c-axis. So for these two components, one goes slower than the other. Okay， 就一个走得快一点，一个走得慢一点。So after penetration through this waveplate, the two components get different phase aggregation， 是不同的相位累积。好，那这不同的相位累积造成的结果就是，它重新再叠加起来的时候，得到的偏振状态跟送进来的时候不一样。知道意思吗？好，我们这个东西的用法就是，我不能，我如果只让电场平行于其中一个，不管光轴或垂直它的话，就没有什么用处。可是如果我送出我的一个偏振，它的方向是这两个成分都有的时候，那这两个成分呢， 一个对应到比较大的折射率，一个对应到比较小的折射率，所以它穿过这一片这个 wave plate 的时候，累积的光程差不一样，就是累积的相位不一样。而这相位不一样，就改变了这两个成分叠加的相对相位。那两个成分叠加的相对相位改变了 ，polarization state 就改变。OK， 好 ，polarization state 就改变。啊，我们第3章学过啊。We have learned in chapter 3 that the relative phase between the two polarization components define the polarization state of this polarization. Okay, so use the wave plate since we have two specific axes providing two different refracting indices. We send a beam of light having polarization in between these two specific axes, so we can separate the polarization into two components, one along the z-axis direction, the other perpendicular to it. Then, after penetration through this wave plate, these two components get different phases. So the relative phases between these two components be changed by this wave plate. So we can use wave plate to change the polarization state. Okay? So now we consider how to calculate the effect of the wave plate on the polarization state. Okay. First of all, let me denote the slow axis as S and the fast axis as F. These two directions follow the principal axis or optical axis of this crystal. And I use X and Y to denote the coordinate axis of the laboratory. 好，我们到这边为止，我们做了一个改变。我们在前面，我们所有的坐标都参考晶体本身的主轴。啊，我们把主轴的3个轴叫做 x 轴、y 轴、z 轴。但是我们现在换掉，我们的 x、y 是实验室坐标的轴的方向。So now we change our convention. Now x and y represent the axis of laboratory frame. Laboratory 就是实验室啊 ，laboratory frame. And we denote the principal axis as S and F. OK， 好，就是你现在都把它想成单轴晶体就好，我们现在不要复杂化啊，就不用把它想成是双轴晶体啊。To be more for the sake of simplicity, you can imagine that we always use uniaxial crystal as our wave plate. So the S or F, one of them be the optical axis or principal axis. OK， 好，就是单轴晶体的话，它的光轴会属于某一个主轴，但是双轴晶体不会啊。For biaxial crystal, the optical axis have different direction from the principal axis. Okay, but for uniaxial crystal, we have only one optical axis, and this one optical axis must be one of the three principal axes. OK， 好，就是主轴是代表 epsilon YZ 的那个轴，但是光轴是什么？是那个双层结构的那个交叉点的那个方向，就是那个刚刚说那个肚脐，啊，从原点往肚脐的方向延伸，那个方向是光轴。好，那单轴晶体的时候，就是你的 nx 跟 ny 一样，或者是 ny 跟 nz 一样，或者 nx 跟 nz 一样。那这时候呢，两个光轴就会合并变成一个，那合并到的方向就刚好是主轴的其中一个。OK， 好，所以这边为了简单起见，你就想象这个全部都是单轴晶体。好 ，So for simplicity, you can always think the wave plate of uniaxial crystal, and the slow axis or fast axis, one of them is the optical axis or C axis. Okay, so now we want to study the effect of wave plate on an arbitrary polarization state.好，课本呢，它是把这个当 x 轴，这当 y 轴，然后把那个方向当 z 轴。我把它反过来，啊，原因是因为呢，我们还是比较习惯用右手坐标系，啊，那这作者有时候左右手坐标系会交互运用，啊，那个有时候会乱掉，我这边还是习惯用右手坐标，好 ，so we use right hand coordinate system, which means that this is x, y, and this is the z direction. Use your right hand to find the orientation of these three axes. So, suppose the angle between the slow axis and the x-axis is psi, which is also equal to the angle between the fast axis and the y-axis. And suppose we have originally a Jones vector of the polarization given by Vx and Vy. Now we want to find V prime. This is the polarization state of the input light. Okay, we want to know Vx prime, Vy prime, the output the polarization state of the output light. Let me denote the unit vector along the x direction as x hat, and along the y direction as y hat, and the unit vector along the slope axis as es, and along the fast axis as ef. So if I want to know the components of the v vector, I can write the v vector as vx times x hat plus Vy times y hat. Okay? And I can also write it as Vs times Es plus Vf times Ef. Okay? Because this is the same vector V. So if I want to know the relation between Vx, Vy and Vs, Vf, okay, then what is Vs? Vs is equal to Es dot V, because now Es and Ef are perpendicular to each other, and both of them are unit vectors. Now I substitute use this. So I get Es dot x times Vx plus Es dot y dy. Okay. The angle between Es and x is psi. So this gives us cosine psi, because both of them are unit vector. So we have cosine psi times Vx plus the angle between Es and y is half pi minus psi. So this inner product gives us sine psi dy. Okay. Similarly, we can derive Vf. Vf is equal to Ef dot V, and this is Ef dot Vxx plus Vy y. So we have Ef dot x times Vx plus Ef dot y times Vy. And the angle between Ef and x is half pi plus psi. And the angle between Ef and y is psi. This gives us the minus sign. Psi Vx plus cosine psi Vy. So finally we have Vs Vf is equal to Vx Vy times cosine psi sine psi minus sine psi cosine psi. Okay. Coordinate transformation. Okay. So we can denote this matrix as R psi. We can denote this matrix as R psi. So if we want to know Vx, Vy from Vs, Vf, we can just multiply R inverse psi to Vs, Vf. However, R psi is the so-called rotation matrix. rotation matrix. For rotation matrix, its inverse is just the rotation matrix use the negative angle. Okay. This is because rotates zero angle is equal to identity. Okay. So we can write Vs as R psi times Vx Vy. And after penetration through this wave plate, we get Vs prime, Vf prime. Okay. And this Vs prime, Vf prime also can be written as R psi times Vx prime, Vy prime. Okay. So if we want to know Vx prime, Vy prime, we use R inverse psi times Vs prime, Vf prime. Okay. So now we want to discuss what is the effect of this wave plate if we use the SF frame. It is easy to see that Vs prime is equal to exponential minus I Ks times the thickness of the wave plate times Vs. Here L is the thickness. And the Vf prime is equal to minus I times K fast times L times Vf. Here Ks means Ns times omega over C. And the K fast equal to N fast times omega over C. Okay. Here slow or fast means one of them is O, the other is E. So Vs prime is related to Vf Vs through this relation, exponential minus I Ns omega over C times L, 0, 0, exponential minus I Nf omega over C times L. Okay. And if I denote the difference of them as gamma, and the average of them as phi, then I can write the result as， 抱歉，这边写错了啊，这边是 S， 这是 F 啊。Sorry。Vs prime at Vf prime, this is equal to exponential minus I phi times this Vs Vf exponential minus I gamma over 2 exponential minus plus I gamma over 2. Okay. 好，把这两个的差，光程差的差啊，不是光程差，相位差啊，相位差叫做伽马，然后平均的相位就中间的相位值叫做 phi， 我们可以把它写成这样，好，写成这样啊。那写成这样的时候呢，这边有一个重点是这样啊，就是说 ，this common factor is useless. This factor is useless. 因为我们在讨论这个 correlation state 的时候，两个 component 共同去乘上一个 factor， 那个 factor 是无用的，不管它，我们只看它相对的 factor. Okay, so we can ignore this factor. Can be ignored. 我们把它丢掉，不要它，然后把剩下这部分呢，取一个名字叫 W0， 好，叫 W0。所以这时候我们就可以这么做啊，就说 ，So now we can write the result as Vs prime Vf prime is equal to W0 times Vs Vf. 那现在我们再注意看，就是 Vs prime Vf prime 是 R psi, so we have R psi times Vx Vy, and W0 times R psi Vx prime Vy prime. Okay. And this is equal to R psi times Vx Vy. So finally we have this So finally we have Vx prime Vy prime equal to R inverse psi times W0 times R psi times Vx Vy. Okay? And we can define this as W times Vx Vy. Vx Vy. Here, this W is R inverse psi W0 times R psi, or R minus psi W0 R psi. So this W matrix represents the effect of this wave plate on the polarization state. Okay. In fact, the real effect comes from this W0. If we use the slower, faster coordinate axis, the result is very simple to predict because for these two polarization direction, the phase differences. You get two different phases, okay? And these two metrics just to rotate our coordinate axis from the slow fast axis to the laboratory coordinate. So 这两个其实是只是转换到实验室坐标用的，真正的作用是在这里。好，真的 the physical effect comes from this W0 matrix。OK， 好，我们今天讲到这。好。